Welcome to Deep Dive, where we slice through the noise of automotive innovation. Today, we're exploring how virtual replicas, advanced data, and smart materials are reshaping the car industry.
I'm pumped about this. So where do we start? Is it with digital twins?
Exactly. Digital twins are like living, breathing virtual replicas of physical vehicles or components. They mirror real world conditions in real time, letting manufacturers test and tweak without a physical
Yep.
prototype.
And that means if something goes awry physically, they already have a virtual model predicting it, right?
Right. It's all about real time monitoring and predictive maintenance. Manufacturers can tweak designs and even forecast potential failures, essentially giving them a crystal ball for engineering decisions.
That's wild. It sounds like a huge shift in how products are built and improved over time.
Absolutely. And it doesn't stop there. Digital twins are powered by the industrial Internet of Things. Think of IoT as the nervous system that links every sensor, actuator, and device to create a seamless cyber physical system.
So how does that interplay exactly? How do these layers come together?
Picture it like an orchestra. At the edge, you have the sensors. These are the individual players. Then, the platform acts as the conductor, processing data through analytics and AI in the cloud. Finally, the enterprise level is like the audience, using that refined data to
Right.
make key decisions.
I love that analogy. It really brings home the idea that every piece, no matter how small, is vital to the harmony of manufacturing.
Exactly. And speaking of AI, it's playing a pivotal role in tackling what engineers call intractable physics, problems too complex for traditional simulations.
Intractable physics? That's a pretty epic term. Are we talking about things like aerodynamics or tire dynamics under extreme conditions?
Yes, indeed. AI takes massive data. Yeah, it's like processing vast numbers of variables in moments. For instance, our AI models for aerodynamics can deliver outcomes in a tenth of a second, which makes real time adjustments almost feasible.
Hold on a minute. So are we just handing over control to these speedy AI systems? It almost feels like engineers might lose some control over the process.
Not at all. It's more about augmentation than abdication. The AI does the heavy lifting for the routine, repetitive stuff, leaving engineers free to innovate creatively.
Exactly. Got it. Now, moving on a bit, what about integrated chassis control? I've been reading about this ICC and how it coordinates so many vehicle functions.
Right, ICC is the backbone of a next gen vehicle's dynamics. It synchronizes everything from electrified powertrains, brake by wire systems, to active suspensions and even four wheel steering. It's all about making the car as responsive
Yep.
and safe as possible.
And I guess that's where simulation really shines, because testing this all physically would be incredibly expensive and restricted by regulations.
Precisely. With physical tests being limited, only a handful of places even allow partial testing. Simulations let engineers run rigorous, safe tests virtually. It's like rehearsing a whole performance without stepping on stage.
I see. And when it comes to verifying these simulations, tools like virtual sensors and extended Kalman filters come into play, right?
Exactly. EKFs help combine data from inertial measurement units and optical sensors to provide accurate real-world estimations, even under extreme conditions. Siemens, for example, uses their Simrod electric sports car to validate these virtual models actively.
That makes sense. Now, switching gears a little, what about electric vehicles? The shift from combustion engines to EVs must present a whole new set of challenges.
Absolutely. EV design is like a whole new ball game. There are 5 primary challenges, starting with the freedom and complexity of a new vehicle layout, adopting human-centered design, managing thermal performance for batteries, integrating ever more complex systems, and adapting to a rapidly changing supply chain.
Right. And isn't it striking how EVs cut down complexity? I mean, going from over 4,000 parts to just around 200 in the powertrain must radically simplify maintenance.
Exactly. That reduction not only slashes costs but also boosts reliability significantly. The streamlined architecture means simpler production, easier maintenance, and ultimately a more sustainable product lifecycle.
Yep. Speaking of sustainability, let's talk batteries. Battery tech has evolved, but what really stands out nowadays?
Well, battery evolution is a long story, from the voltaic pile to lead acid batteries. Today, it's all about lithium ion cells, which offer higher energy densities and longer ranges. They're even key to projects like the Hornsdale Power Reserve that stabilize grids and thereby accelerate EV
Uh-huh.
charging infrastructure.
Hornsdale is a huge example. Stabilizing grids with massive battery storage really highlights the broader impact of these advances beyond just the car itself.
Exactly. It's not just about mobility, but also about integrating renewable energy sources and ensuring our power infrastructures are resilient. This, in turn, supports faster, more sustainable charging
Yeah.
solutions.
Now, let's step inside the car, the cabin innovations. I heard automakers are creating ultra-sustainable interiors. What's happening there?
Right, sustainability is expanding to include the very materials that shape the cabin. Major suppliers are developing things like EcoSphere, 100% melt recyclable foam used for seats, and BMW is pioneering non petroleum leather and plant based flax fibers for lightweight recyclable
Yep.
parts.
That sounds like a perfect recipe for a circular economy, using materials that you can repurpose over and over.
Exactly. It's about closing the loop, reducing waste, and cutting down chemical and water consumption in the production process. These innovations redefine what sustainable really means in automotive design.
But with all this digital connectivity, isn't there a growing concern about cybersecurity? How do these connected systems protect themselves from threats?
Oh, absolutely. The more connected our systems get, the wider the attack surface becomes. From simple sensors to massive cloud data centers, every component is potentially
Yes.
vulnerable.
And it's not just random hackers. We're talking about advanced persistent threats, organized crime, and even state-sponsored groups, right?
Exactly. For instance, consider how malware like Frosty Goop has targeted industrial protocols, attacking critical OT systems. The increased incidence of ransomware, being involved in over half of all manufacturing attacks, really puts the spotlight on the need for robust cybersecurity strategies.
I'd say that's a bit alarming. It sounds like these companies must shift towards proactive cybersecurity measures, like identifying non-tolerable events and plugging potential attack paths early on.
Precisely. Maintaining an accurate inventory of connected assets, rapid patch management, network segmentation, and rigorous staff training are now essential. After all, over 50% of successful malware breaches come from phishing and human error.
It's definitely a continuously evolving chess match between defenders and attackers.
So, when you step back and look at this whole ecosystem, from digital twins and IIoT to integrated controls, EV design, and cybersecurity, it's clear that automotive engineering today is a marvel of interconnected innovation. Vehicles are becoming smarter, safer, and more sustainable, transforming not just how we drive, but how we
Right
live.
on. It makes you wonder, as cars get more autonomous and connected, how will our very experience of driving evolve? What metrics will define comfort, safety, or even the joy of the ride?
Exactly. The future isn't just about automation, it's about curating that personal, immersive driving experience we all crave. The blend of advanced data, smart infrastructure, and sustainable design will reimagine mobility in ways we can only begin to imagine.
Fascinating insights. It feels like we're just scratching the surface of this revolution. Thanks for diving so deep with me today.
The pleasure's been all mine. Stay tuned as we keep watching and reporting on these game changing advancements in automotive engineering.